All right, this is an introduction to balancing chemical equations or reactions. All right, so we're first going to start off just by looking at this. It represents a chemical reaction where the lowercase letters are usually numbers and the uppercase letters are usually compounds or atoms or elements. So the first thing we have to know is what the reaction is made out of. And so if we look right here, these are called reactants because they react. And then these over here are called products. And a few more vocabulary words or terminology that you need to know. The numbers in the front are called coefficients. And if you have a little number down here at the bottom like this, that number is called a subscript. All right, so when we talk about an equation, a lot of students, I meet a lot of older people, and when they find out I teach chemistry, they say, oh, I didn't understand anything, especially balancing equations. And if you can't balance an equation, then you can't do the rest of the chemistry. So you need to know first why you have to balance the equations. So we're going to come down here for a second, and I'm going to write this. Let's see. Yeah, down here. All right, so there's a law called the law of conservation of mass. And the law of conservation of mass says you cannot destroy or create matter. And so what that means for chemistry and balancing equations is that the mass of the reactants has to equal the mass of the products, right? So over here I'm going to write mass of reactants has to equal the mass of the products. That's the total mass. So that's all the products and all the reactants added together. All right, so let's look at an equation real quick and see what the mass is on both sides. So we're going to look at this one. And if I look at a periodic table and I look at the mass for iron, I find the mass for iron is 56 AMU. And the mass of oxygen is 16, but there's 2 oxygens, so that's times 2. So it's 32 AMU. And then in iron 3 oxide over here, we'd have 2 iron, so that's 56 times 2, which is 112. And then we have 3 oxygens, which is 48. Oh, I'm sorry. It's not 48. I did the math automatically. It's 16 times 3. And that's 48. And so 112 plus 48 is 160 AMU. And so if we look at this, the total mass of the reactants on the reactant side is going to be 88. And the total mass of the products is 160. And so you can see here this clearly does not equal each other. And so this is violating the law of conservation of mass. We have more mass on the product side over here than we have on the reactant side. And so we're creating mass. Mass is just popping up from nowhere. We have an extra iron over here. There's 2 of them. There's only 1 here. And we have an extra oxygen. there's 3 over here, and only 2 here. So we have to balance this equation and make the same number of ions on this side as we have over here, and also have the same number of oxygens on the reactant side as we have on the product side. So this can be very frustrating. There's lots of techniques out there. This is one that I came up with, and it works 90% of the time for a regular reaction. Okay, so what you're going to do is you're first going to balance the metals. Let's see, I'll write it up here. You're first going to balance the metals, and then you're going to balance the nonmetals. And then next, you're going to balance the hydrogen, and then after that, the oxygen. So metals, nonmetals, hydrogen, and then oxygen. All right, so let's start this. Iron, we're going to start with iron because it's our metal, and we have only 1 iron on this side, and then there's 2 irons here. So I know that I'm going to have to put a 2 in front. You cannot ever change the subscript. Okay, you can only put a coefficient in. You can never change these little numbers here. I wouldn't be able to put a 2 here because iron doesn't exist like that. Okay, so you can't change the compound. You can only put a coefficient in the front. All right, so we've done the metals, and then there are no other nonmetals. There's not a hydrogen, but now we have to do oxygen. And so I've got 2 oxygens here, and I've got 3 oxygens here, and this leads to a big problem. You cannot make 2 3, and you cannot make a 3 a 2. So what we're going to do, so that we don't have to use fractions in this class, is we're going to simply make the odd number even. So if you have an odd number on one side and an even number on the other, you're going to make the odd number even. And you do that by multiplying by 2. So I'm going to write that down here. Okay. If there is an odd number on one side and even on the other, make the odd number even by multiplying by 2. So the odd number here in this case is 3. So we're going to say we need 2 of these, which then goes back and changes the number of irons that I have, because now I have 4 irons. So I need to go back and make sure that I change this 2 right here to a 4. So now I have 4 irons on this side and 4 irons on this side. And so now I can finish and balance my oxygen. I've got 6, 2 times 3, 6 oxygens over here. So I need 3 oxygens over here. Now a lot of times students don't see this. They want to add or do some crazy stuff, or they don't think this applies to this. This number right here is saying we have 2 of all of this. We have 2 iron 3 oxides. So if we have 2 of these, I'm going to write down 2 of them. I have 4 irons and I have 6 oxygens because it's applied to everything. All right, let's do a few. I think I have 6 examples, and then we'll be done. So in this first example, I'm going to start with metals, right? I'm going to write it over here, MnHO. So I'm going to do metals, nonmetals, hydrogen, and oxygen. So I'm going to start with silicone because there are no metals, so I'm going to go straight to nonmetals. So silicone, there's 1 here, and there's 1 here. So silicone is good. Next, nonmetals, I've got chlorine here and chlorine here. And I have 4 chlorines on this side. and I only have 1 over here. You cannot write a number down here like this. Okay, you can't put a 4 down here. That would change that. It wouldn't be hydrochloric acid anymore. We're not changing the reaction. We're balancing it. So I have to put a 4 right here. So now my chlorine is balanced. So next I'm going to go down to hydrogen, and I've got 4 hydrogen on the product side, right? 4 HCl, so that means I have 4 hydrogen, and I only have 2 over here. So that means I need 2 more waters, or 2 waters total. And so that gives me 4 hydrogen on this side. And then next I can go to oxygen, and I've got 2 oxygens here, and I've got 2 oxygens here, so this reaction is balanced. And I would make sure that I put the 1s in there, because a good question on a test or a homework assignment or something would be, what is the sum of the coefficients of the balanced reaction? And so the sum here would be 8. But if you didn't write those 1s in, you might be tempted to pick 6. And so that's a really good trick question. All right. In the next problem, we're going to do something a little bit different. We're not going to separate the polyatomic ions. So as you can see here in this problem, there are 3 ammoniums, and there is 1 phosphate. And over here we have an ammonium, and we also have phosphate. So we don't have to break those apart. You can keep them all together. If you see that the polyatomic ion is the same on both sides, you have phosphate here and phosphate here, you have ammonium here and ammonium here, you have nitrate here and nitrate here, then you don't have to break those apart. All right, so like I was saying, sorry about the interruption, we're going to keep those polyatomic ions together, and we consider them to be nonmetals. So you don't have to count the individual atoms like the phosphorus and the oxygen and the nitrogen. You can keep them all together with the ions. Okay, so we're going to start with the metals, right? And the metal in this reaction is lead, and I have 3 leads right here and only 1 lead right here. So that means I have to have 3 lead 4 nitrates. And next I'm going to go to the nonmetals, and so I'm going to use nitrate next because it's attached to the lead that I just balanced. And I have 12 nitrates. I have 3 of this whole thing, and each one of those has 4 nitrates in it. So I've got 3 of those, right? I've got PbNO3 4 3 times. So that means that I have 4 plus 4 plus 4, which is 12 of them. And on the product side, I only have 1, right? There's only 1 NO3, so I need 12. So I'm going to put a 12 right here. So after that, I'm going to go to ammonium, and I have 12 ammoniums right here. And I've only got 3 ammoniums right here. So I'm going to need 4 of them to give me 12. Right? We multiply here. We're not adding. 3 times 4 is 12, 4 times 3 is 12. Okay? So after that, I'm going to go to phosphate. And, oops, I've got 4 phosphates, right? 4. And each one of these ammonium phosphates has only 1 phosphate in it. So I've got 4 phosphates here, and I've got 4 phosphates here. This reaction is balanced. All right, let's do one more. This is a combustion reaction. You can tell combustion reactions because they're reacting with oxygen. And this happens to be what we call a hydrocarbon. We make carbon dioxide and water whenever we burn hydrocarbons. So that's going to be something we talk about soon, the different types of reactions. All right, so I'm going to start with metals, and I don't have any metals here at all. So next I'm going to go to the nonmetals, except for hydrogen and oxygen. There are only 1 carbon, or there is only 1 carbon here and 1 carbon here, and so carbon's balanced. So next I go to hydrogen. There are 4 hydrogens here, and I've got 1 water, so I have 2 hydrogens there. So I'm going to need 2 waters to give me 4. And then after that, I'm going to go to oxygen. I've got 2 oxygen over here, but I have 2 oxygen here, and I also have 2 oxygens. That looks like a 20. That's oxygen. And then I've got 2 oxygens from here, right? Because I have 2 waters. And each water has 1 oxygen. So I have 2 from there and 2 from there. So that's 4 oxygens total. And so I'm going to need 2 right there. And then this reaction is balanced. I have 1 carbon, 1 carbon, 1 carbon, 4 oxygen, 2 and 2 is 4, and 4 hydrogen and 4 hydrogen. All right, let's do a couple more. All right, let me write my little thing over here, MnHO. So I'm going to start with gold. I've got 2 golds right here on the reactant side, and I've got 1 gold over here on the product side, so I'm going to make this 2. All right, next I have 3 sulfurs here and only 1 sulfur here, so I'm going to make this one 3. And then next I have to do hydrogen. So I've got 6 hydrogen on this side, 2 hydrogen on this side, so I'm going to need 3 of these. And then that one is balanced. All right, next we're going to do the metals first, like always. I've got 2 vanadiums on this side, and then 1 vanadium here on the product side, so I'm going to put a 2 here. All right, and then I'm going to go to chlorine next. So I've got 6 chlorines on this side, right? 2 times 3 is 6. And so I'm going to need 6 of these. And now I have 6 hydrogen. So I'm going to need 3 here, right? I've got 6 hydrogen here, and 3 times 2 is 6, so 6 hydrogen there. So now I need to balance my oxygen. And I have 5 oxygens right here. And I've got 2 oxygens here. And I've got 3 oxygens here. And so that means I have 5 over here and 5 on the reactant side, and so that reaction is balanced. All right, let's do one more. So we start with the metals. Here's mercury, and mercury is over here. There are 3 on the product side and only 1 on the reactant side, so I'm going to put a 3 here. And then next I'm going to go to phosphate. So I have 1 phosphate here and 2 phosphates here. So I'm going to need 2 of these. Now I can't keep hydroxide together on this side because it's not on this side. There's a way to do it with this, but I'm not going to go into it here. I might go into it when we talk about these types of reactions. So you have to be careful when you do this because hydrogen is split up on the reactant side, which is unusual. So we've got hydrogen here, right? So there's 6 hydrogens because there's 2 OHs in every single one of these compounds here, right? There's 2 OHs in every single one, and we've got 3 of those. So that means that we have 6 hydrogens here. Whoa, what's going on? My pen went away. 6 hydrogen here, and then we also have 6 hydrogen right here, 2 times 3. And so that gives me 12 hydrogen altogether. And so I'm going to need 6 waters to give me 12 hydrogen over here. And so next I can go to oxygen. I've got 6 oxygens on this side. And we don't have to count the oxygens in the phosphates because they were already counted when we balanced the phosphates. So I only have to worry about the oxygens right here. and I have 6 oxygens. So that reaction is balanced. I promise that you start to find a groove with these, and they get really easy. You just have to keep practicing. So keep it up, and it'll click. If you need more help, please come and get some.